Hello everybody. We have discussed in the previous class regarding the basics of rotatory motion chapter in physics. Now let us continue the same chapter by considering the important most aspect of that chapter, which is moment of inertia and thereby the applications related to that. In fact, we all know very well the moment of inertia is nothing other than the inertia of a rotating body. Generally, we people used to speak out moment of inertia as mk square, the formula. M being mass of the body and k is called radius of gyration, or in other words, you can even call this one as RMS radius of that particular system. When we consider RMS radius, when radii are taken R1, R2, R3 and so on and so forth, then what will be the value of k then? It is root of R1 square plus R2 square and so on up to Rn square whole divided by n. That is root of mean of the square values of radii. That is what we call it as radius of gyration, or you can otherwise call it as RMS radius as such. So about moment of inertia while discussing, we have to remember two different theorems. One of course is parallel axis theorem and one is perpendicular axis theorem. When we consider parallel axis theorem, I is equal to ICM plus m into r square. That is a general formula, where of course you can understand when a lamina is taken this way, this is the axis through which moment of inertia through center of mass can be calculated. If I just want moment of inertia which is parallel to this particular axis, in fact the distance of separation is between them, if I take it as r, then I can be taken as ICM plus mr square. That is the corresponding equation which is called parallel axis theorem as such. Exactly like that, I of z axis is equal to Ix plus Iy. Moment of inertia along z axis is equal to moment of inertia along x axis plus moment of inertia along y axis. This particular equation we can take it as the perpendicular axis theorem as such. So most of our problems now are going to be based on parallel axis theorem, perpendicular axis theorem, or sometimes both. So this is actually the concept what we people are taking up. In addition to this one, what is angular momentum also we have to deal with. Angular momentum is nothing other than I omega. Likewise, torque also. Torque is nothing other than rate of angular momentum, which of course we call it as I alpha. So these are the major equations based on which we people are discussing few problems today. Let us now check the very first problem, please. An automobile engine develops 100 kilowatt power when rotating at a speed of 180 rpm. The torque it delivers will be how much? That is the general concept. In fact, power of course is given as 100 kilowatt. Kilo in the sense it is 10 cube. Therefore, I can write 100 into 10 cube watt. That is now going to be the power. But of course, 180 rpm. Yesterday also and the earlier class also we have discussed 180 rpm is nothing other than by 60. When we write it, that will be 180 by 60 rps. That is nothing other than 3 revolutions per second, which is the linear frequency of the body. Then automatically we can write omega is equal to 2 pi n, the formula, where from I can write 6 pi radian per second is going to be the angular velocity. Now if you go for the analogy, generally torque we people used to take up like this, torque and power. Power in general is nothing other than torque into angular velocity. That is the equation what we have to discuss. So what will be torque then? It is power by angular velocity. In fact, power is equal to force into velocity in linear dynamics. That force is analogous to torque here and that velocity is analogous to omega here. So directly if you write P by omega, P is of course 100, that is given 10 to the power 5, directly 100 into 10 cube you can write. By the value of omega what has been taken here, that is nothing other than 6 pi radian. if you just take this simplification factor, if you directly take up this simplification, naturally you will be getting so many Newton per meter as the value there. See that option once again, all of you. That option over here is now tallied with 531 Newton meter. This is the value. So what you people should understand is the analogy, if you remember, it is very simple and easy for you to get it. Power in linear dynamics, we people used to take it as force into velocity. In rotational dynamics, we people used to take that one as a torque into angular velocity. That is the concept. Now come to the next one, the second equation. Second problem. The handle of a door is at a distance of 40 centimeter from the axis of rotation. If a force of 5 Newton is applied on the handle in a direction 30 degrees with the plane of the door, then the torque produced. In reality, torque you can even define it like this also. Torque is nothing other than force into perpendicular distance. Perpendicular distance between what? Between the fulcrum and the point of application of the force as such. So when you talk about this torque here, this also can be taken in vector form this way, R cross F. Cross product yields sin theta, we know it very well. So RF sin theta, that is the corresponding formula. What are the values given over there? You see, R is given 40 centimeter, that now will be 0.4 meter as such. Into F, what is the force that is applied over there according to the problem? It is 5 Newton. What is theta mentioned? 30 degrees. Sin of 30 is now going to be half, which cuts over here 0.2 times. So 0.2 times 5 now is going to be simply 1 Newton meter. That is actually the corresponding answer. That means the key for this one is supposed to be with the second one as such. That is the answer 2. Now if you look at the next question over here, that is problem number 3. 4 point-sized bodies, each of mass m, are fixed at 4 corners of a light square frame of side length L. The moment of inertia of the 4-body system about an axis perpendicular to the plane of the frame passing through its geometric center. One has to understand the arrangement carefully here. There is a square frame he is talking, but at the same time he has given you that square frame is a light square frame. Means what? The mass of this square frame need not be considered. Only the masses which are placed at 4 corners are now to be taken up into consideration. So 4 masses, each of capital M, are placed like this. And you can understand like this, the point, whichever is the point of intersection of the diagonals, that point now becomes the geometric center of that frame as such. Now our axis of rotation is perpendicular to this plane passing through the geometric center. That is what is very, very clearly given. Axis perpendicular to the plane of the frame and passing through its geometric center. That is the concept. So along this one, when we take, there are 4 bodies. What is the side length given? It is L. Then each distance from the center will be L by root 2. This distance is L by root 2. Even this also is going to be L by root 2. All the 4 values are L by root 2 each. Now what is moment of inertia? When many a number of bodies are there, sigma mr square, we people used to write the formula for that. Sigma stands for the sum here. Now how many bodies we have? 4. All of them are having the same mass, same distances as well. Therefore 4 times m into, what is the distance here? L by root 2 whole square. This is supposed to be the total moment of inertia of the system. What is L by root 2 whole square? L square by 2. 2 gets cancelled in 4 twice. Therefore 2 ml square will now be the corresponding value. 2 ml square stands for the third option over here. See the third option carefully there, 2 ml square. So what will be the total value of moment of inertia of the system now? It will now be 2 ml square as such. So this is question number 3 what we are having. Now let us switch over to the next number, that is 4th problem as such. The position of axis of rotation of a body is changed such that its moment of inertia decreases by 36%. The percentage change in its radius of gyration will be how much? One particular method I just want to mention over here. In fact, we know well the concept of moment of inertia when we generally take it up. You will be finding that I is equal to mk square, the formula. We all in fact know that formula well. Now here moment of inertia decreases by 36%, and what happens to the radius of gyration? So overall I can write I is proportional to k square. That is official formula for us. When I is k square, moment of inertia is decreased by 36%, it is given. Therefore, let us take the original moment of inertia as 100. And we write this equation, 100 is proportional to k square is my first equation as such. Now if you take 36% when it is decreasing, for every 100, 36 is the decreasement. That means what will be the present value here? It now must be 64. When this is decreasing, automatically k also should be decreased by some value. I do not in fact know that value. Therefore, I take the decreasement as x there. Then automatically I can write this one k minus x whole square, which is now the second equation for me. So what I can directly write? I just take the ratio of this k minus x whole square by k square, that is now going to be 64 by 100 as such. You can certainly understand when I take root on both sides, here root cancels, the square cancels. This becomes 1 plus x by k. This now becomes 8 by 10, which of course is 4 by 5. Now just look at this one. What is the value of x by k from that one you calculate? What is x in fact? It is a change in the value of k. That means change in radius of gyration by original radius of gyration. That is what officially we call it as the fractional change in radius of gyration. This value now is 1 minus 4 by 5, which now becomes 1 by 5. Now I want the percentage change. That means what should I do? This value I should multiply it by 100. How much I am getting here? 20% I am getting. 20% what? Since these two are directly proportional to each other, since I is decreasing here, k also should be decreased by 20%. That means what is the correct option over there? It decreases by 20%. That is the third option is the correct option for this particular question. This model is a very commonly asked model in different entrance examinations, in different chapters of physics as well. Not necessarily be in the same chapter you can be asked this model question. Now let us switch over to question number 5. What is that question over here? A diatomic molecule is formed by two atoms which may be treated as mass points m1 and m2, joined by a weightless rod of length r. Then the moment of inertia of the molecule about an axis passing through the center of mass of the system perpendicular to the rod will be how much? If you just look at, this is a linked up model with center of mass in fact. You people can understand that there is a diatomic molecule he is just imagining there. One is of mass m1 here, the other one is of mass m2 here, and the separation distance that has been mentioned over here as r. That means these two are directly being connected by a distance say, or separated by a distance say small r like this. Now if I take this is the center of mass of the system, the distance to the center of mass from the first body if I take r1, second body if I take r2, then I can write directly r1 will be m2 by m1 plus m2 into r. That is the formula. And the second one, r2 is equal to m1 by m1 plus m2 into r. That is the equation for r2. In fact, masses are known to you and the distances to center of mass are known to you. So what will be the moment of inertia? m1 r1 square plus m2 r2 square. r1 is known, r2 is known. Simply substitute the values and take the common factors there. m1 into this much square if you take up this way, m1 into m2 square by m1 plus m2 whole square into r square. That is actually the equation, first half of the equation, plus what is this second one? m2 into r2 square means m1 square by m1 plus m2 whole square into the value of r square as such. Now come on, take whatever the common things you can take up. m1 m2 square in the numerator, here also here m1 square m2 in the numerator. So you can directly take that one out, m1 m2 if you take common. By this m1 plus m2 will be left over into r square, that is the corresponding simplified form of that equation. That means what is the correct option over here? The third option is going to be the correct option for us. That key is going to be the third one. So this is actually the concept which is a linked up model with the center of mass that is attached to moment of inertia concept here. Let us now check the next number please. That is question number 6. 4 point sized bodies, each of mass m are fixed at 4 corners of a light square frame of side length L. The radius of gyration of the system about an axis perpendicular to the plane of the frame passing through its geometric center is. In fact, the same question we people have dealt with earlier, right? By just calculating what is moment of inertia, we have calculated. 4 bodies like this we have taken up. Each one is of mass m like we have considered. And of course, all the 4 are placed at the corners like this. And length is L of this side, right? And of course, you can understand this is the center. Each distance will be L by root 2. I have already told you that point earlier also. Now, what will be the moment of inertia here? Moment of inertia actually we have got 2ml square. That is the formula what we have got officially. Moment of inertia 2ml square means, can't you write that is equal to mk square according to the formula please, where k is going to be the radius of gyration. What is this m now? It is to be taken as the total mass. What will be the total mass here? 4m, because 4 different bodies we have, each of mass m there. So 4m will now be the total mass. Now what will be k square? Is it not 2ml square by 4m now? So m getting cancelled, 2 cancels here twice. Then what is left over? L square by 2 that is left. But what is the value of k is my question. Is it not L by root 2 now? So what will be the correct option for this one again? The third option is going to be the right option for us, which is L by root 2 as such. So earlier and present questions, only difference is earlier we have been asked to calculate moment of inertia. Now in this particular case, we have been asked to calculate what is the radius of gyration of the system as such. Let us now switch over to problem number 7 now. A bit different model this time. A ballet dancer is rotating at an angular velocity omega on a smooth horizontal floor. The dancer folds his body close to his axis of rotation, by which his radius of gyration decreases by 1/4 of his initial radius of gyration. His final angular velocity will be how much? Ballet dancer, when the ballet dancer is rotating, one should understand that angular momentum that remains constant. That is the condition for this particular rotation of the ballet dancer. What is angular momentum? I1 omega 1 must now be equal to I2 omega 2. That is the general equation what we people used to take. Now omega is angular velocity he is talking about, and smooth horizontal floor. Dancer folds his body close to his axis of rotation, by which his radius of gyration decreases by 1/4 of his initial value. So in fact we can write mr square here into omega 1, that omega 1 is given as omega there. Now m is common. What is radius of gyration? What is happening to that one according to the problem? Decreases by 1/4. Wonderful wording here. Decreases to 1/4 is different from decreases by 1/4. because decreases by 1/4 means still the body has got 3/4 of the value of radius of gyration. It is not 1/4. 1/4 it has been decreased by that much. That means what is remaining? 3/4 that is remaining. 3/4 r whole square in place of this I can write. This value now can be taken as omega 1. Now if you cut this m off, this r square over here you can cut that one as well. When you take this r square like, what will be left over here? 9 by 16 omega 1 is equal to omega you are getting. 9 by 16 in the sense, what will be omega 1 is the question. 16 omega by 9, that must be the corresponding value. That means what is the correct option? You just pick up there. The fourth option is going to be the correct option for us. 16 omega by 9 will now be the valid answer. Only point to be noted in this particular problem is decreases by 1/4, not decreases to 1/4. Remember the wording difference over here, please. Let us take the next number, that is problem number 8. A particle performs uniform circular motion with an angular momentum L. If the frequency of the particle's motion is doubled and its kinetic energy is halved, then its angular momentum becomes how much? One point we need to remember here, what are the options given? You just look at first. 2L, 4L, L by 2 and L by 4, these are the 4 options what have been given. Now if you look at this one, angular momentum is L, frequency has been doubled and kinetic energy has been made half. Kinetic energy, generally we write that one as half L omega. What is the formula here? You can understand. Half I omega is the formula generally. Half L I omega square is the original formula. Half I omega square. That is the equation officially. But we can write I omega as L. Therefore, I omega into omega, if I write half L omega, I can write. Now the question here is, what is angular momentum? The question. So L can be written twice kinetic energy by omega. That in other words, I can write twice the kinetic energy by omega can be written 2 pi n over here. N being the linear frequency of the body. Now what are given? Therefore, you see, if the frequency of the particle's motion is doubled, that means n is doubled and kinetic energy is halved, then how to write this one? L1 by L2 is equal to KE1 by KE2 into N2 by N1. This is the formula you have to take up. That means L is directly proportional to kinetic energy, L is inversely proportional to linear frequency. Now what is kinetic energy 1? We don't know. I write it KE1 as it is. But according to the problem given, kinetic energy is halved, he is talking. That means KE2 now is KE1 by 2 over here. That is the point. Into, what is N2 now? Frequency is doubled, he said. So it should be written twice N1 by N1 as such. Now this 2 also goes up. Kinetic energy cancels, N1 gets cancelled, 2 into 2, that now becomes 4. Then what will be L2 the question? Is it not L1 by 4 please? If I take the original value of angular momentum as L, what will be the corresponding value now? It should be L by 4. That means the correct option in this particular question is supposed to be the fourth option there. That is actually L by 4 here. This is the methodology we people have to adopt for doing such model question as such. Now let us take the next number, problem number 8 as such. Moment of inertia of a flywheel is 0.2 kg meter square, which is initially at rest. A constant external torque of 5 Newton meter acts on the wheel. The work done by this torque during 10 seconds is how much? That is the concept. In fact, you people can understand directly. The wording says initially it is at rest. That means initial angular velocity of the body is 0. Fine. Moment of inertia is given 0.2 kg meter square. That is the value given to us. And what is the torque that is acting? torque is given 5 Newton meter, that is the value provided. But truly speaking, torque is equal to I alpha. Then automatically you can understand from this particular equation, alpha is equal to torque divided by I, which is 5 by 0.2 as such. That 0.2, 5 by 0.2, is it not 25 now? Because 0.2 can be written 2 by 10, 50 by 2, that is 25 watt radian per second square. That is the value of alpha. And what is the time that has been given to us? Time is given 10 seconds over here. Alpha is known to you now. Omega initially 0 we know, and time also has been given to us. What is the question that is asked? What is work done is the question. Work done means nothing other than force into distance in linear dynamics or displacement, whatever you call it, according to the case. Now work done in this case to be taken torque into theta. What is that theta? Now you should calculate that one separately. How to write theta please? Half alpha t square. Ut plus half a t square formula. When you apply that one, half alpha t square, you can directly write that one. Now when you take half alpha t square here, alpha being 25, t square being 100. So you can cut this to 50 times. Now you can write 1250 what? Radian. That is going to be the value of theta. And what is the torque that has been given? You all know that is given 5, and this is 1250. Therefore, what will be work done now? 5 times 1250. Right? Whatever the value you will be getting directly, work is in joule, automatically you can take up. So it will now become 6,250, exactly 6250 joule. That will be the corresponding answer. That is corresponding answer means what must be the option now? It should be the fourth one. So 6250 joule, this is the method in which we calculate work. One thing all of you should understand here, whether you are calculating work done here or force here or acceleration here, whatever it is, they are all analogous to linear terminology also. So if you can identify that analogy carefully, it's not a difficult task in remembering the things over here. Now let us check the next number please. Problem number 10. The angular momentum of two rotating bodies are equal. If the ratio of their moments of inertia is 1:4, the ratio of their rotational kinetic energies will be how much? That is the concept. Angular momentum is equal. That is the thing he has given. Two rotating bodies are equal. L1 is equal to L2. Angular momenta are equal. That is the concept. Now you can write angular momenta are equal means what is the ratio he is asking you? Ratio of kinetic energies he is asking. What is the kinetic energy formula? Half I omega square. That is the general equation. Now what are the values given? Moments of inertia 1:4, that is given there. The ratio of moments of inertia I1 is to I2, that is given 1:4. That is actually the concept. And what is the case now? Angular momenta are given L1 is equal to L2. And what is the value here? The ratio of their rotational kinetic energies. Rotational kinetic energies, when I values are given, L is equal to I omega formula is known to all of us. When L values are equal, I1 omega 1 is equal to I2 omega 2. That is the formula you can write, from which omega 1 by omega 2 can be written as I2 by I1. What is I2 by I1 please? 4 by 1. So omega 1 by omega 2 you have got, I1 by I2 also you know. Then what will be kinetic energy 1 by kinetic energy 2? It is I1 by I2 into omega 2 square by omega 1 square. That is the concept. What is I1 by I2 given? 1 by 4. What is omega 2 by omega 1? 1 by 4, of course, I1 by I2 1:4. Omega 2 by omega 1 again will be 1 by 4. So 1 by 4 whole square, like 1 by 16 you people can take up. So ultimately 16 by 1 you will be getting. That means what will be the total ratio here again? You will be getting that option as 4:1 like that. Just look at that option once again please. The fourth option that now is going to be tallied there. That is the concept. So this is question number 10. Now let us check the next number please, problem number 11, right? A metal rod of uniform thickness and of length 1 meter is suspended at its 25 centimeter division with the help of a string. The rod remains horizontally straight when a block of mass 2 kg is suspended to the rod at its 10 centimeter division. The mass of the rod is how much? In fact, we all know in this rotatory motion the conditions for equilibrium of a body. That of course we can write clockwise sum of moments must be equal to anti-clockwise sum of moments. That is the one. Now here he is talking about 1 meter long wire, that is rod, which is suspended here at which position? 25th centimeter it has been suspended. Then automatically we can all understand exactly at 50th centimeter the mass of this particular body or the weight thereby that is going to act. But in reality when you suspend at 25th centimeter the total system will now be tilted this side. But what has been given in the problem? A 2 kg mass is suspended over here. At what distance it has been suspended? It is suspended at 10th centimeter. Such that the total rod is perfectly horizontal. That has been made like that. So you can understand this is perfectly horizontal now means what will be this distance from the fulcrum to this application of force? That is now 15 centimeter. What is this particular distance please? This is 25th centimeter and this one is 50th centimeter. That means what is the distance between them? 25 centimeter. So clockwise moment and anti-clockwise moment acting on that system are supposed to be equal when the system is in equilibrium. Then what should we write? W into, what is this value? 25 must now be equal to 2 into, what is this particular distance? 15. So you can now write W itself is equal to 30 by 25 which is 6 by 5 that is 1 by 2. Kilogram weight like we can say. When it is kilogram weight, what is the mass is the question. Then automatically mass becomes 1.2 kg as such. That is nothing other than the third option over here which is being tallied. Look at that option once again, third option, that is 1.2 kg, that is actually the mass of that particular rod. Right? Let us now check the next number, that is problem number 12. There are two bodies given in this one. This type of a model is a very commonly asked question at Eamcet level. Two identical circular plates, each of mass 0.1 kg and radius 10 centimeter are joined side by side as shown. This is the circular plate 1. This one is the circular plate 2. Right, they are attached like this. This is the center here, this is the center for the second body as such. Now what is the question? Their moment of inertia about an axis passing through their common tangent. This is the tangent which has been given in the problem. It is given in the figure itself. This is the axis of rotation of the body now. What will be its total moment of inertia along this particular axis which is a common tangent for both of them? Now here you should understand, for this plate along the line passing through center of mass, what is moment of inertia we know. What is moment of inertia now to be taken here? It is mr square by 4. That is along the diameter we used to say. Now what is this perpendicular distance? R. If I consider this is ICM and this one is moment of inertia along this line, that is I, according to parallel axis theorem, ICM plus mr square will now be the total moment of inertia along this axis. Then what is going to be the value here? ICM is mr square by 4 plus mr square. How much you will be getting now? 5 mr square by 4. That is for how many bodies? One body. But you are having how many bodies over there? 2 bodies you have. Therefore, I should multiply this one by 2. Then what will be your answer ultimately? 5 mr square by 2. If r is given, the radius over there, you can directly calculate what is the value of moment of inertia. Now substitute the values. 5 mr square by 2. 5. What is mass that is given? 0.1 kg. It's very clearly mentioned. R square, it is 10 square centimeters. That in the sense 100 centimeter square. 100 centimeter square can be written 100 into 10 power minus 4 meter square whole divided by 2. Now you can directly cut this point with this 0. And this 2 and this goes over here 5 times. So 25 into 10 power minus 4. That is the value. But it has been given in the problem 2.5 into 10 power minus 3. This is kg meter square. This is the corresponding moment of inertia. So if you look at the second option is supposed to be the correct option for this particular question. Look at that one, 2.5 into 10 power minus 3 kg meter square is the corresponding value there. Let us now take the next number, problem number 13. That also is once again a problem linked with a small figure there. There are again 2 different bodies given. What are those 2 bodies you look at? 2 circular rings, each of mass capital M and radius r are attached to each other at their rims and their planes are perpendicular to each other as shown. The moment of inertia of the system about a diameter of one of the rings and passing through the point of contact. One ring is like this taken up. Another ring is taken up this way. This is the axis he has given. That is touching this ring and it's moving across the diameter over here. Then what will be the moment of inertia about the diameter first of all? mr square by 2. That is its moment of inertia. And we know very well along this particular axis it is mr square, the formula for a ring. Now what is this particular distance, perpendicular distance? R. Then what is its moment of inertia? mr square plus mr square. It will now be 2 mr square. That is actually the value for this one because we just have to go for the moment of inertia along its natural axis plus mass of this ring into the perpendicular distance square between them. And what is this value? mr square by 2. So what will be the effective moment of inertia? 2 mr square plus mr square by 2, which now becomes 5 mr square by 2 as such. Just look at those options what have been given there. It is 5 by 2 mr square means the third option is supposed to be the correct option for that. That is the concept. Now let us take problem number 14, which in fact has been given in one of the Eamcet examinations recently. A uniform circular disc of radius r lies in the xy plane with its center coinciding with the origin of the coordinate system. Its moment of inertia about an axis lying in the xy plane parallel to the x-axis and passing through a point on the y-axis at a distance y is equal to 2r is I1. Let us now take till that extent first of all. He is now talking about an xy plane like this. And of course, what is the body given? It is a circular disc that is given. It is given in such a way that the center coincides exactly with this center over here on xy plane. That is the question. Now, where is the point he is talking about? On x-axis and passing through a point on the x-axis at what distance? Y-axis. At a distance y is equal to 2r. This is y-axis, you can understand. Y is 2r. There is a point which is at a distance 2r from the center. What is the axis? Axis is passing parallel to x-axis. That is what has been given. Parallel to x-axis means this particular value. It is given I1. Now what is it he is giving? It's a moment of inertia about an axis lying in a plane perpendicular to xy plane passing through a point on x-axis at a distance x is equal to d. Let us consider this distance is d. But where is the axis he is talking? Perpendicular to x-axis. Earlier it is parallel to x-axis he is talking. Now he is talking perpendicular to x-axis. That moment of inertia value is given as I2. What is I1 first of all you work out. You can understand this line is, this axis is parallel to this axis passing through the diameter. Then what will be the value of I1 now? According to parallel axis theorem, this is in fact a disk. Along the diameter, it is mr square by 4 plus the perpendicular distance being 2r, that is m into 2r whole square. We people can write. This is parallel axis theorem. So you can write directly this one, mr square by 4 plus m into 4r square as such. Now 4 for the 16 mr square plus mr square, 17 mr square by 4. That is the value of I1 given in the problem as such. Now what will be the value of I2? Perpendicular axis we have to take, this axis we have to consider, and along this natural axis for this disk we will be getting the moment of inertia as mr square by 2 plus what is this perpendicular distance? D. Therefore it can be taken md square. This is the value of I2 that has been given in the problem. So it is now mentioned that I1 is equal to I2. That means I definitely can equate them now. While equating, what will I get? md square will be equal to 17 mr square by 4 minus mr square by 2. If I just take 4 as LCM here, 17 mr square minus 2 mr square, which now becomes 15 mr square. But of course this m and this m gets cancelled. What is his question there? What is the distance d the question? Now square root you take, root 15 times r by 2. That must be the value. But in this problem, it is mentioned the distance as capital R. Then automatically this becomes root 15 into capital R by 2. This will now be the corresponding value for this value of D. Which one is tallied there? Once again you look at question number 14. Third option is root 15 r by 2. So that is the correct option for us, which of course for the question number 14. Now let us take the very next problem please. That is problem number 15. I is a moment of inertia of a thin rod about an axis perpendicular to the length of the rod and passing through one end of the rod. If half of the length of this rod from free end is cut and removed, then moment of inertia of the remaining rod about the same axis will be how much? Now if you look at a rod concept, a rod is just taken up. This is the rod. This is the axis which is at one end he is giving us. If I consider its length as L, its mass as m, what will be moment of inertia first of all? You can understand it is ml square by 3. That is the formula for moment of inertia along an axis perpendicular to the length of the rod passing through one end of the rod. Now what is he talking? Half of this particular rod is now cut and removed. That means this much portion is now cut. Then what will be the moment of inertia? If I take it as I1, along the same axis means same formula to be taken. But when half of it is cut, what will be the present mass? It will now be m by 2. What will be the present length? It will now be L by 2 whole square by 3 I will be getting. So what will this value be now? ml square by this 2 square 4 times 2 8, 8 times 3 it is 24. This is the value of I1. This is the second one and this one the first one. Now what is the question over there? In what way these two are related is the question. I now can write I1 by I. If I take it is ml square by 24 into 3 by ml square. ml square gets cancelled, that gets cancelled, this cancels 8 times. So what will be I1 now? It must be I by 8. So what is the corresponding option over there you see? It should now be the third option once again. It should be I by 8. That is a corresponding number there. Now let us switch over to the next problem, that is problem number 16. The moment of inertia of a brass solid sphere about an axis passing through its center is 1.6 kg meter square. The moment of inertia of another brass sphere of radius half the radius of the first sphere about its natural axis is how much? For a brass sphere or any metal sphere or any other sphere as such, moment of inertia will be 2 by 5 mr square. This is the formula. But in this particular case, he did not mention what is the value of mass of that sphere. But one thing we can understand, mass is proportional to r cube. What for? Mass can be taken 4 by 3 pi r cube, which is the volume, into density, that is rho. All these things are being constants. M is proportional to r cube, I can write. When I write M is r cube, then how to write this I value now? I is proportional to r cube into r square, that is r to the power 5. That is the concept. So how to write this equation now? I1 by I2 is equal to R1 to the power 5 by R2 to the power 5. That is the ultimate formula you have to take up. Then what is it he is giving? Radius is made half. That means what? R2 is given R by R1 by 2. Now write that value here. R1 to the power 5 by R2 is R1 by 2. R1 to the power 5 by 2 power 5. 2 power 5 is how much now? 32. 2 to the 4, 4 to the 8. 8 to the 16, 16 to the 32. So 32 comes up. So it is now going to be 32 for us. What is I2 the question now? It is I1 by 32. What is I1 value he has given you? You see there 1.6 it is given by 32. You directly can write that one 1 by 20, which is 0.05. You look at those options once again. 0.05 kg meter square means, again it is a third option that is being tallied there. That is the corresponding answer you people have to remember. Right? So this is 16th question. Now let us check the 17th number, which of course is a match the following model question. Of the same body, moment of inertia along different axes that has been asked there. Match the following for moments of inertia of a thin circular plate about a different axis of rotation. About any diameter is first one, any tangent in its plane the second one, about its natural axis the third, about any tangent perpendicular to its plane. All the four directly I will write them. It is moment of inertia of a thin circular plate about any diameter. First diameter if I take, moment of inertia is mr square by 4. It is a plate. And what is the second one? About any tangent in its plane. Tangents in its plane means this is the tangent you have to take. Then what will be moment of inertia? According to parallel axis theorem, mr square by 4 plus mr square. That means how much it will now be? 5 by 4 mr square. That is for the second one. About its natural axis, the third one. Natural axis means what? About the axis passing through center of mass perpendicular to its plane. About that one, what will be value of I? It is mr square by 2 for a plate like. And what is the next one here? That is a tangent perpendicular to the surface. Perpendicular in the sense, how to remember that one? If I consider this is the ring, this is the tangent what he is talking. Then what will be moment of inertia? Along the center of mass it is mr square plus mr square. How much it will now be? 2 mr square as such. Now look at for the first one mr square by 4. That means for A, it should now be 1/4 mr square. That means A stands for F. And what is the second one? 5 by 4 mr square. That means B stands for G. And third one, what is the value? I is mr square by 2. That of course is H, that is corresponding to that. And fourth one obviously be 2 mr square, of course you will be getting there. That is what it has been given in a wrong way. 2 mr square it should be now. That is actually the mr square by 2 plus mr square, sorry. It will now be 3 by 2 mr square. That now becomes the very first option. That means for A, it is going to be mr square by 2. That is A for F. B for G, C for H and D for E. Automatically the second option that is going to be tallied there. That is the concept. Now check the next problem, that is problem number 18. Moment of inertia of a uniform horizontal solid cylinder of mass capital M about an axis passing through its edge and perpendicular to the axis of the cylinder when its length is 6 times its radius. In fact, a solid cylinder, you should consider that one as a rod cum a solid disc like. This is a solid body. This is the axis what has been given. Then what will be moment of inertia? With respect to the length of this rod, ml square by 3, that is the formula. With respect to the diameter, passing through the diameter of a disc, it will be mr square by 4. But what is the concept here given? He has given you the length is 6 times the radius, that means L is 6R. So you can write m into 6R whole square by 3 plus mr square by 4. Whatever the value you people are getting here, this now becomes 36 mr square by 3 plus mr square by 4. Now this goes 12 times. 4 times 12, 48 plus 1, 49 mr square by 4 will now be the corresponding answer. What is 49 mr square by 4? Which option that is tallied there? Option number 4 there is exactly 49 mr square by 4. That is the concept. Now let us switch over to problem number 19 here. A circular ring of mass capital M is rotating about its own axis in a horizontal plane at an angular velocity omega. If two point-sized bodies each of mass m are gently attached to the rim of the ring at two ends of the diameter, then the angular velocity of the ring will be how much? In fact, when you are talking about a ring like this, I1 omega 1 must be equal to I2 omega 2. That is the concept. What is the actual mass given? M. So you can write mr square into omega 1. That is the concept. Is equal to m plus how much is attached to that? 2m into r square into omega 2. R square getting cancelled. Then what will be omega 2 now? m omega 1 by m plus 2m. That is the corresponding formula. That means which one that is tallied? Directly option 1 is going to be tallied there. That is the corresponding answer for us. Now look at the next number, that is problem number 20. The length of seconds hand of a watch is 1.5 centimeter and its mass is 7 into 10 to the power minus 3 gram. Its angular momentum is how much? That is the concept. In fact, we know very well angular momentum L is equal to I omega. What is I for a seconds hand or minutes hand, whatever that is? It is ml square by 3 into omega. What is the value for omega? In the case of a seconds hand like, it is 2 pi by 60 or pi by 30. This is actually the value. Now if you look at this, mass is given there. How much it is given? 7 into 10 power minus 3 gram. That means 7 into 10 to the power minus 6 kg. Into what is the length given? 1.5 whole square, length square means 2.25 into 10 to the power minus 4 meter square by 3 into pi by 30. Pi you can write 3.14. Come on, simplify that one. Whatever the option that is given over there, if you look at that options carefully, which option that is correct you look at now? It is the second option, 5.5 into 10 to the power minus 11. Exactly you will get if you simplify this one. So this is the formula what you just have to look into. One of the very, very important models. Now let us come to the next number, that is problem 21. If Earth shrinks such that its density becomes 8 times to the present value, then the new duration of the day in hours will be how much? Earth is spinning on its own axis means definitely angular momentum of that particular Earth is supposed to be constant. That means I1 omega 1 must be equal to I2 omega 2. What is I1? 2 by 5 mr square into omega 1. It is 2 pi by 24 hours it takes to complete one rotation, we all know that, is equal to what? Earth shrinks to 8 times, density is becoming 8 times. Density is becoming 8 times means radius is going to be doubled, because density is mass by volume. We can understand that one. So radius is being doubled. How to write this one? 2 by 5 m into 4r square into how much? 2 pi by T2, like. That is the point. Now you can certainly understand what is the value. The radius is going to become half, so it will be 1 by 4. Now 2 pi gets cancelled. Now mr square, of course 2 by 5 mr square gets cancelled. What is left over? 4T2 is equal to 24. Then what will be T2 now? Exactly 6 hours. That means if at all Earth is shrinking in such a way that its density is becoming 8 times, like, then what will be the corresponding duration of a day? That means 6 hours. Means you can understand, now it is 24 hours, we all know that. That means every 6 hours Earth completes one rotation. That means in a day's time of 24 hours, you will be having 4 days according to this. That is the concept. So which particular option is correct over here? That is option number 3. So that is 6 hours over here. Only thing you need to understand here, density is becoming 8 times means radius is becoming half. That is the ultimate concept you people just have to remember. So if you look at all these cases, very commonly asked question from rotatory motion, 99.9% cases will definitely be from either moment of inertia part of it, or the angular momentum concept of it, or for that matter the value of torque that is acting on a rotating body, that also they may ask us. And at the same time, usually 2 marks weightage you will be having for this particular topic at Eamcet level. 90% both the questions may be asked based on moment of inertia, or one on that and one on the rest of the chapters, like that. So I hope all of you might have followed what we people have discussed these 2 days as far as rotatory motion that is concerned. Next time we are just taking up the next lesson over here, that is gravitation, in which we are dealing with the planets which are just moving in circular orbits over there, or elliptical orbits, whatever they are according to the case, and likewise what is escape velocity, orbital velocity and other things like. We people are just going to take up those points over here. So I hope all of you might have got what exactly we have discussed as far as rotational dynamics that is concerned. So all the best for you people as far as this chapter that is concerned, right? Good luck to all of you.